Solve the differential equation dy by dx minus 3y equals 7. I'm gonna ask you to pause the video, write this question down, and solve it. Now, I have already done some work on it, and the answer I got was y equals negative 7 over 3 plus ce to the 3x. Right? Y equals negative 7 over 3 plus ce to the 3x. I'm going to ask you to try and see if you get that. Well, provided I didn't make any mistake, but go ahead with it. Okay, so you're finished? Let us see how this goes. Now here, you can see that this is in the general form, dy by dx plus py equals q. And the integrating factor is equal to e to the integral of p dx. You remember that? Need to remember that. Alright? Now, rewrite it, dy by dx plus negative 3y equals 7. So you can see that p is equal to negative 3 and q is equal to 7. Alright? So that's what we have there. Now, the integrating factor is equal to e to the integral of p, which is negative 3 dx, which is e to the, well, when you integrate negative 3 with respect to x, what do you get? You get negative 3x. Alright? So that's what you get there. So the next thing you do, multiply both sides by the integrating factor. So you have dy by dx minus 3y equals 7. You have e to the negative 3x dy by dx. So it's e to the negative 3x dy by dx minus 3y. Oh, let's put the e to the negative 3x first. Hold this there. Alright. Let's put the negative 3 first then. Negative 3 and then e to the negative 3x times y. Alright, let me write it this way. It's negative 3y, but I'll put the e to negative 3x between them. Alright? Equals 7 times e to negative 3x. Okay. Now, here, you can see that the left hand side is the result of having performed a differentiation of a product of two functions of x. Alright? So we're going to apply the reverse product rule. Now, what did you, or just before we do that, remember what we have is the derivative with respect to x of uv, where u and v are both function of x, the general form is to say you hold u as it is, differentiate v, plus you hold v as it is, differentiate u. Let's remove the dx from here. So the derivative of uv, well, I just remove the dx from under each of the u's to make it less crowded. So what we have here, the derivative of uv is u dv plus v du. We differentiate uv with respect to x. You hold u as it is, multiply by derivative of v, plus you hold v as it is, multiply by derivative of u. Alright? Now what did you hold and what did you differentiate? Obviously, here you differentiated y. You hold e to the 3x as it is, differentiate y. Plus, oh, this is e to the negative 3x. So you hold e to the negative 3x as it is times differentiate y. That suggests that one of them is y and the other one is e to the negative 3x. Let's see what the other part says. Then you see here that you hold y, or you differentiate e to the negative 3x, you get negative 3 e to the negative 3x. So clearly, one of them is y and the other one is e to the negative 3x. Let me put it this way. So it is the derivative with respect to x of e to the negative 3x times y. That is equal to 7e to the negative 3x. Alright? After that now, you integrate both sides. You find the integral with respect to x. That means x is the variable. Alright? If you see any other letter in the function, it's a constant. However, here y is not a constant. We already established that y is a function. So here, what we have is the integral of e to the negative 3x, which is a function of x, times y, which is another function of x, but we're differentiating with respect to x, a variable. Right? If there was a z, or a, b, c, whatever other letter, those would be considered constant, unless you already established that another letter is a function. Alright? So the dx equals integral of 7e to the negative 3x dx. Now remember, when you are integrating a number times a function, you can always put the number outside the integral sign. Makes the process less crowded. Alright? You have to remember that when you add a constant of integration, the 7 also multiplies the constant of integration, but then 7 times a constant is just another constant. But anyway, here, oh, how could I leave that off? I put the integral sign, but I did not put back the d by dx. The d by dx should go there. Now here, you integrate the derivative of a function, the function is left undisturbed. Right? It's just like when you square the square root of a number or a function, the number or the function is left undisturbed. Alright? Because heaven, what do you get now? You integrate e to the negative 3x, you have e to the negative 3x divided by negative 3 plus a constant of integration c. Now, you do this by integration by substitution. I do it mentally, right? You should You should practice your integration by substitution to the point where you can now do it mentally in many cases like this. Alright, so we have e to the negative 3x times y is equal to, well, this now would be 7 over 3, or negative 7 over 3, e to the negative 3x plus 7c. So here now we want y, so let's divide both sides by e to the negative 3x. So we have y equals negative 7 over 3 e to the negative 3x over e to the negative 3x plus 7c over e to the negative 3x. But you can see what happened here. Y equals negative 7 over 3. E to the negative 3x will cancel e to the negative 3x, right? Plus, now, if you have something divided by a number to a power, it's the same as that thing multiplied by the number to the negative of that power. So it's 7c times e to the, well, negative 3x is positive 3x, right? But then at the same time, 7c is just another constant. So how can we rewrite this? Let's put the positive part in front. Call it d. D, a constant d, e to the 3x minus 7 over 3, right? Or, well, k is a more popular letter to use as a constant. Constants usually written as c or k, right? But if you have run out of c and k, you could use another letter, maybe p and then q, the next most popular letters to use as constants, right? Alright, so there we have it. So it's a constant times e to the 3x minus 7 divided by 3.